let's talk. We're going to continue on here this week. We're going to talk about matrices. We're going to need to use matrices for next week, and next week is we're going to solve systems of equations using matrices. Okay? And it's a great tool for you. We'll keep it simple, but it's a great tool for you, like if we were last week with 3 systems and 3 equations. It's a very efficient tool to solve those because you can organize things in the matrix form and use what we're learning this week to then solve those matrices, and it makes it go, instead of having last week we were averaging probably half of a page per problem-ish. Okay? With matrices, 4 lines, maybe. Okay? Okay? So it takes the same math and it whittles it down into it. Okay? So the very first thing that we need to talk about here is what a matrix is. Okay? Matrix is the singular, matrices, matrices, is the plural. Okay? So matrix, matrices. A matrix is a rectangular arrangement of numbers organized into rows and columns. Okay? I'm going to highlight rows and columns because that is key in matrices. Rows and columns. Rows are the horizontals, columns are the verticals. Okay? Matrices, and that's the plural, are named using capital letters, okay? And each individual number is called an element. So for instance, we have matrix A, okay? And we have to do 2 things when we're telling somebody what matrix A is. The first thing that you have to tell them is you have to tell them what. I'm not quite sure why that all of a sudden got ungrouped. Maybe. Well, I'll fix that later. The first thing that you have to tell them is you have to tell them what size matrix A is. And we tell the size of a matrix by the rows first, the number of rows, then the number of columns. So matrix A here is a 2 by 3 matrix. Okay? So when you're saying that, you're saying, okay, matrix A has 2 rows and 3 columns. Matrices are always, write this down, always rows by columns. Matrices are always rows by columns. Okay? So that's the first thing that you have to tell somebody when you're talking about a matrix. So you have to first tell them what size it is so that they know. The second thing that you do is when you're reading off the matrices elements, you read them left to right, top to bottom, just like you were reading a book, and you pause after each row. Okay? So if I were telling you matrix A, I would say matrix A is a 2 by 3 matrix, 3, -2, 4, 1, 0, -5. Pause after each row, but kind of like gotta reset the typewriter, okay? And then go through. Okay? I don't know why these didn't line up. Leave that. Why didn't these group, ungroup? Each element has an address, and that address is the row that it's in and the column that it's in. So the number 3 has an address because the number 3 is right here. It has an address of the first row, first column. So it's in element 1, 1. -5 is an element in matrix A. It's in the second row, third column. So its address is 2, or it's 2, 3. Okay. Again, the dimensions are always rows by columns. Rows by columns. It's the number 1 rule of matrices. Always rows by columns. We can do things with matrices. We can add them, we can multiply them, we can subtract them, we can invert them, we can determinate them. Well, that we'll get to all this week. Okay? Okay? So, if we are doing adding and subtracting, the sizes of the matrices have to be exact. So rows by columns of the first one have to be the same as rows by columns of the next one, has to be the same as rows by columns of the third one, and so on and so forth. However many matrices you have, they all have to be exactly the same size. If they're not, if they are not the exact same size, you cannot add or subtract them. You cannot. No solution, not possible, whatever you want to say there. Okay? Can't be done. They have to be the same size. Okay? And that's not a lie. Okay? That is the mathematical truth of the truth. Okay? They have to be the same size. So, in this first one, if they are the same size, and you will find that when you're dealing with matrices, you will always be doing a dimension check first. Okay? So this first matrix has 2 rows and 2 columns. The second matrix has 2 rows and 2 columns. These dimensions are exactly the same, so therefore we can add them. Adding and subtracting of matrices is relatively non-painful, I think is the best way of saying it, because you just take the corresponding elements and you add them together. So I would take 4 here and add it to 2. Then I would take 0 and add it to 7. Then I would take -6 and add it to -1. And lastly, take 2 and add it to -5. So the resulting matrix then is a 2 by 2 matrix, 6, 7, -7, -3. The resulting matrix will also be the exact same size when you're adding as if you can add them. Yeah. You try example number 2. Minus -3, -5 minus 0, 10 minus -2, and -4 minus 4 gives me a 2 by 2 matrix of 6, -5, 12, -8. And yes, you need to have the brackets around the outside of it. And those have to be brackets. Straight lines mean something different that we'll get to next. I forgot to mention that. Okay. Matrices have brackets around the entire outside. Questions, comments, concerns, clarifications on that particular one? Okay. Adding and subtracting, again, relatively painless. Okay. NTC likes these problems, and back when we were out of the textbook also loved these type of problems. So I've kept them in there because NTC will possibly throw one at you on the final that you will have to take at the end of the semester. Okay. So what you do is you kind of just do the adding of the matrices over here on the left side. Okay? So you'd have -2 plus -3. You'd have 1 plus 6. You'd have x plus 7. And you'd have -5 plus 4. So you'd have the matrix -5, 7, x plus 7, -1. And that has to equal -5, y, -2, -1. And once you have that, once you have equal matrices that are of the same dimension, the corresponding elements have to be equal. So, -5 has to equal -5. That is true, so we have a true matrix going on. 7 has to equal y. There's one of our answers. X plus 7 has to equal -2. So x then would have to be -9. And -1 would have to equal -1. So the answers here, we're asked to solve for x and y. X is -9, y was 7. Okay. The next thing that we can do with matrices is there are 2 different types of multiplication. The first type we're going to deal with today, and that's called scalar multiplication. Okay? The other type, matrix multiplication, where we take two matrices and we multiply them together, we will be dealing with tomorrow and Wednesday. Tomorrow there is a video that you need to watch prior to Wednesday's class. Okay? It will be a very brief video. It will be under 10 minutes. However, it is extremely important that you watch that video before Wednesday. Because if you don't, you will be lost on Wednesday. Okay? And I took matrix multiplication and I broke it up into the two parts. The first part, the important part, can you do it, can you not do it, is Tuesday's video. Wednesday's class will be all about the actual multiplication of two matrices. Okay? Scalar multiplication is different than that. Scalar multiplication is like the distributive property just on a matrix. So what you're going to do is you're going to take this outside of the matrix value and you are going to distribute it into all of the elements inside the matrix. So negative 3 times 3 is negative 9. Negative 3 times 2 is positive 6. Negative 3 times 1 is negative 3. Negative 3 times negative 10 is positive 30. And that's that. Okay? That's scalar multiplication. It's the easier of the two multiplications, which is why we can do it today. Now that we have scalar multiplication in our toolbox, we can take adding and subtracting matrices to the next level, where we can have a scalar multiplication and an addition going on at the same time. So please try this at this time. So 4 times the first matrix would give me a 2 by 2 matrix of 8, 12, negative 4, and 20. To that, we are still going to subtract off the other 2 by 2 matrix, which is legal because we can, because they're the same size. 8 minus 6 is going to be 2. 12 minus negative 4 is going to be 16. Negative 4 minus 1 is going to be negative 5. And 20 minus 5 is 15. So my resultant answer is a 2 by 2 matrix, 2, 16, negative 5, 50. Questions, comments, concerns, clarifications? Love it. No? Try that. I think I did 2 number 5s here. That's all right. I'll fix it for later. So if we multiply the first matrix by 1/4, 8 times 1/4 is 2, because it's like 8 divided by 4. Negative 12 times 1/4 is negative 3. 0 times 1/4 is 0. 4 times 1/4 is 1. Look at that. Then we have to add to that twice the second matrix here. 2 times negative 3 is negative 6. 2 times 7 is 14. 2 times 1 is 2. 2 times negative 2 is negative 4. So we get that. then we can add those two matrices together. 2 plus negative 6 is negative 4. Negative 3 plus 14 is 11. 0 plus 2 is 2. 1 plus negative 4 is negative 3. So my end answer is a 2 by 2 matrix, negative 4, 11, 2, negative 3. Yes? Love it. Again, NTC loves these type of problems. They have been on multiple finals over the course of the years, and especially where you combine scalar multiplication and addition and subtraction. So please do this one at this time. So if we multiply here by 3/4, that's going to be negative 1. No, take that back. Negative 3. Let's go by 1/4. So negative 3, 0, 6, and 3/4 y. And we're still going to add to that 3, 9, 7, 4. And so then that's going to be negative 3 plus 3 is 0. 0 plus 9 is 9. 6 plus negative 7 is negative 1. And 3/4 y minus 4. And that is going to equal x, 9, negative 1, 5. So the first one says that 0 equals x. The second one says 9 equals 9. The third one says negative 1 equals negative 1. And the last one says 3/4 y minus 4 equals 5. So we got a little bit of algebra to do on that one. And so we would add 4 to both sides first, giving us 3/4 y equals 9, multiplied by 4/3, or multiply by 4 both sides, then divide by 3 both sides, and that's going to give me y equals, multiply by 4/3, those cancel, multiply by 4/3, 9 divided by 3 is 3 times 4 is 12. So my answers here are x equals 0 and y equals 12. Yes? Love it. And that is all that I have for matrix operations, basic matrix operations. I do apologize in advance for week 22's worksheet. We lost the ability to do math type. Math type was a phenomenal program and let us, make worksheets and all this fun stuff. And so I stole the worksheet. I created my own, but it doesn't allow me to give extra space for work. So sorry about that the problems are stacked one on top of one another. But you can do now, and still probably get these problems done yet in class today, you can do problems 1 through 6 on week 22's worksheet as of right now. Okay? So 1 through 6. Again, I remind you also that tomorrow there will be a video for you to watch. Less than 10 minutes, promise. Okay? I pinky swear. If anybody wanted to pinky swear on it, okay? That'll be less than 10 minutes. Okay? But that gotta watch that prior to Wednesday. Okay? Important stuff. That's all I got for you. Make sure that you get homeworks done, formatives done, all that fun stuff. Get that stuff done. Stay on pace.